All right, guys, so today we're going to do 12.5, day number 1 of sigma notation. Today you're going to do expanding and evaluating the sum. So first we're going to start with sum notation. So for sigma notation, you can see it's a capital E, that's a Greek sigma. And you can see how everything's kind of labeled. So the N is going to be the starting value, and then the K is going to be the maximum value, or you could think about it as the term that you end with. And then the A sub N, you guys should be used to from everything else that you've done. That's just your general equation that you are going to use to plug into your formula. So this is what all of your problems will look like today in the sigma notation. And then sigma stands for sum. So the goal of today is to find the sum of all of these things. And this second notation is what's called the expanded form. So having them written all out is called the expanded form. So for some problems today, you're going to expand it before you find the sum. So that's how your answer should kind of look for some of your problems. Okay, so we're going to start with some examples. So we're going to expand and we're going to find the sum. So for this first one, we're finding the sum of 2n minus 7, where n equals 1 up to 4. So the first thing you need to figure out is what kind of sequence this is. So since it's 2n minus 7 and there's no exponents, you know that this is an arithmetic sequence that you guys have learned about already. So what we're going to do is expand it out, and then we're going to find the sum. So we're going to start at 1, and we're going to go all the way to the 4th term. So we're going to write out first where n equals 1. So we're going to do 2 times 1 minus 7 is our first term, plus, then we're just going to keep writing out until we get to 4. So now it's 2 times 2 minus 7. Plus 2 times 3 minus 7 plus 2 times 4 minus 7. So that's the expanded form. So we have to have that all written out, and then we will simplify that. So 2 times 1 minus 7 is negative 5, plus 2 times 2 minus 7 is negative 3, plus 2 times 3 minus 7 is negative 1, and then 2 times 4 minus 7 is 1. So now in order to find the sum, so our answer is going to be S sub n, that's the sum, is going to equal negative 8. So if we add all those numbers up, our sum should be negative 8. So that's our first example. Okay, so let's try another one. Make this a little bit bigger. So for the next one, we're trying to find the sum of 2 to the j. And then it says j equals 4, and then we're going up to 8. So first thing, again, we have to figure out, is this arithmetic or geometric? And since it has an exponent, we know this is a geometric sequence. So we are going to write it all out again, starting at 4 and stopping up at 8. So first we're just going to expand it. So we're going to start with 2 to the 4th and then add the terms up. So 2 to the 4th, then 2 to the 5th, 2 to the 6th, 2 to the 7th, and then 2 to the 8th. Once we get to that top number, we're done. So now that's the expanded version, and now we're going to find the actual sum. So 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, and 2 to the 8th is 256. So when you add all those up to get the sum, S sub n is going to equal 496. Okay, so then the last example from this page is going to be find the sum, so expand and find the sum of 4 times 0.5 to the I, and then I'm starting at I equals 1 and going up to 4. You will notice that the variables are interchanged, so it doesn't always have to be n, it could be any variable that you have for your equation. So first, again, figure out what kind of problem this is. This is a geometric problem. And we're going to expand it the same way. So we're starting at 1 and we're going up to 4. So we're replacing that I with a 1. So first we're going to do 4 times 0.5 to the 1 plus 4 times 0.5 to the 2 plus 4 times 0.5 to the 3 plus 4 times 0.5 to the 4. So once you get to the 4th, you are expanded. And now we're going to simplify this. So 4 times 0.5 to the first is 2, plus 4 times 0.5 squared is 1, plus 4 times 0.5 to the third is 0.5, plus 4 times 0.5 to the fourth is 0.25. Then we find the sum, add them all up, so S sub n is 3.75. Okay, so what you will notice for these expanding and solving problems, the expanding doesn't take very long. So this one, we only had to do 4 different terms. If you have a problem that has more terms than you want to write out, you will be able to use a different formula, which is what we will do next. Okay, so for this next one, it says expand each and find the sum again. But if you notice, this first problem is going from 1 to 40. So it does not make sense to expand all of this problem. So what we're going to do is just find the first one and the last one. And then we can use the formula that we did before. So for this problem, it's 10n plus 3, so we know it's an arithmetic sequence. So then let's make a list. So a sub 1, we've already practiced this. The first number of our sequence we got to figure out. So if we're starting at 1, we're going to do 10 times 1 plus a 3. So that's 13. Then we're going to do our last one. So our last number we're looking for is 40. So we're going to do a sub 40. So you're going to type in 10 times 40 plus 3, which is 403. So here's our first one, our first term, and here's our last term. So we're going to use those two in order to figure out our sum without having to expand it. So let's write it out. So our S sub n formula for arithmetic is our n divided by 2, so 40 over 2, then times our first 13 plus our last 403. This formula you should already have in your notes from arithmetic. So now we just simplify, so 40 divided by 2 is 20, 13 plus 403 is 416. So then our sum is 8320. Okay, so if you are asked to expand and find the sum, but if it's too big to expand, you do not have to. All right, last one we'll do is going to be find the sum from n equals 3 to 20 of 3 times 2 to the n minus 3. So first thing, if you see that exponent, you know it's a geometric. So when we go to use our formula, make sure you're using the geometric sum formula. So first thing, again, since it's a 20, it doesn't make sense to expand this. So we're going to have to write out our first and our last. So a sub 1, we take our 3 and plug it in. So it'll be 3 times 2 to the 3 minus 3. So if you simplify that, that's gonna be 3. Then our a sub n, our last number is a 20. So we're gonna plug that in, so 3 times 2 to the 20 minus 3. When you simplify that down, you're gonna get 39,3216. Okay, so then we go to our geometric sum formula. So S sub n equals, it starts with your A, so our first number was 3. Then we do 1 minus our R, which is here. So we do 1 minus 2. And then remember, in order to figure out our exponent for our n, you do upper number minus lower number plus 1. So our upper number is 20. So in order to find our n, we do upper minus lower and then plus 1. So our upper number is a 20 minus our lower number is a 3, so that's 17, and then plus 1 would be an 18. So 18 is going to be on our exponent of our formula. Then we divide by 1 minus 2. So once we simplify that, we get 3, 538, 971. So our sum for that one is very big because we're going all the way to 20 numbers for that problem. All right, so your homework for this lesson is 12.5A worksheet. The answer key is posted if you need it. Ask questions in your discussion and kind of see how it goes.